We're given a valid parentheses string that splits into primitive groups, and from each group we want to remove just the outermost pair of brackets. For the input open, open, close, so open, close, close, then open, open, close, close, the outer pair of each group falls away, and we're left with open, close, open, close, open, close. The trick is knowing exactly which brackets are the outermost ones. The clever part is a single depth counter that tells us how deeply nested we are. When we see an opening bracket, it's outermost exactly when the depth is still 0, so we skip it and then increase the depth. When we see a closing bracket, we first decrease the depth, and if we're now back at 0, that closing bracket was outermost, so we skip it too. Every other bracket, the inner ones, we keep. Ordering the depth update carefully is what makes both outer brackets of each group disappear. We build the answer character by character, tracking a depth counter. For an opening bracket, we keep it only if the depth is already above 0, meaning it's an inner bracket, and then we increase the depth. For a closing bracket, we first decrease the depth and keep the bracket only if the depth is still above 0. That way the outermost pair of each group is dropped. Let's build the depth counter live and watch the outer brackets vanish. Start with an empty answer and a depth of 0. Then walk the string one character at a time. On an opening bracket, keep it only if we're already inside, then go one level deeper. On a closing bracket, step back out first and keep it only if we're still inside, then return the result. Now let's test it and hit run. There it is. The first string loses its outer brackets to give open close 3 times. 2 simple pairs collapse to nothing, and the deeply nested one loses just its outermost layer. The flow rides a depth counter. On an opening bracket, keep it only when the depth is already above 0, then go deeper. On a closing bracket, come up a level first, then keep it only if the depth is still above 0. Outer brackets sit at the edges, so they get skipped. How fast? We look at each character exactly once and do constant work, so the time grows linearly with the length. The result string can be almost as long as the input, so the extra space is linear too. 3 things to get right. First, the ordering of the depth update matters. Increase after deciding on an opening bracket and decrease before deciding on a closing one, or you'll keep the wrong brackets. Second, a depth of 0 is the signal that a bracket is outermost. And third, adding to a string with plus is fine for learning, though a list with join is faster for very long inputs.